Hi, welcome again to another demonstration of the power of EOS. My name is Herman Baan, System Engineer with Arista Networks. EOS is an extensible modular operating system and runs on all of our products. Arista EOS is modular in a sense that each software feature or process sits in its own protected address space. It's extensible with open APIs that can even allow third-party applications to run directly on the switch. But most importantly, it's designed to make operations simpler and much more effective. Today, I'm going to demonstrate one of these features called LANZ, and then specifically focusing on the 7500 modular switch. So, what seems to be the problem? Well, Ethernet networks are really sensitive to congestion, causing increased latency and dropped packets. Basically, in current data centers, there are a lot of applications who have problems with this congestion, but these applications are basically flying blind. They are reacting after the congestion or loss of events. So what is the solution, we think? Well, basically real-time buffer utilization analysis. And we do that by giving buffer usage measurements, what really gives a true picture of the congestion. We provide configurable thresholds for warnings, and we give the warnings and alerts to available to a higher level application layer and NMS system which can do something with that information. So the implementation of the LANZ functionality on the 7500 is as follows. We monitor the virtual output queues on ingress real-time in hardware. The system basically pulls the packet processor ASIC every second and reports which queue has been most congested over the preceding second. That information is then reported using the command show queue monitor length. It can be done per interface, it can be done globally to see the congestion over the entire system. And syslog messages are generated with the queue length once the queue length exceeds this configurable threshold. And that syslog message includes information about the depth of the queue as well. I have basically this setup. It's a Arista 7508 modular switch with one line card, or a number of line cards, but we're using one line card with 3 ports. To those 3 ports, aspirant test center is connected. And the picture on the bottom, we see what we're really doing. The modular switch is configured as a layer 2 switch, and background traffic is sent from port 11.6 of the aspirant through port 346 on the 7500 to the output port 348. And what I'm going to do is I'm going to send a very short burst of traffic from port 11.7 to port 347 on the 7500, destined for also port 348, making sure that that amount of traffic is just a little bit above the link speed, so that congestioning is happening. And we're going to show and demonstrate that normal tools like interface counters or SNMP will not show that congestion, but that the queues are really shown on with the queue monitor length command. So here I have the front end screen of the aspirant test center, and what you can see here is that I'm sending traffic from port 11.6 towards port 11.8, and I can demonstrate that it is running on the switch by using the interface counters command, and I'm running from 46 90% to 48 and 90% of traffic. The traffic is running there. What I'm gonna do now is I'm gonna send a burst of packets of 128 byte packets, and the burst size is 50,000, but that could be even smaller. I'm just selected this burst size, and it's just one burst. Let me do that. I start the traffic. Traffic started and already done. It's a very small burst, certainly on 10 gig. But, and you don't see anything on the counter side. I mean, still 90%. So how do I show that the buffers are filled up? Well, I do that with this Q monitor length command. Show Q monitor length. Let's go directly to the interface 348. And what you can see here is that a few seconds ago we saw an increase on the buffer, and the buffer size is this amount of bytes. And let me give a little bit more information about what we see here on the screen. I've actually explained that on this slide. We first see the time, and that time is basically the amount of time when the event happens, and it's updated every time the show Q monitor length command is executed. And you can actually see that there's some congestion in the past as well, and that's basically my test. The interface column shows the destination interface experience congestion. Remember, we measure the virtual output queues, and this is the virtual output queue which are sitting on the ASIC called Ingress port set, and it's the ASIC with a virtual output queues for 331 to 348. And this is the duration of the burst. It's only one second. I can also send a smaller burst, and you will see that the threshold is smaller. Oh, by the way, I forgot one thing, is this queue length, you only get a message if you exceed a threshold. So what is the threshold then? And I can show that with show queue monitor length, sorry, status. And you'll see here the syslog interval. You see the various threshold of the egress interfaces, and if we then scroll to 48, then my threshold is set to relatively low, only 100,000 bytes, so I will get a message very quickly. I can also demonstrate that I have had a syslog message. I do that with show logging last. Let's do 1 hour, and then you'll see this syslog message: Q monitor 6 length over threshold, interface Ethernet 348, and the queue length is over the threshold of 100,000 with the length of 6453792. That information is sent to a syslog server, and basically you can do anything with that if you want. Now let's change the burst size to a very much smaller one, to even smaller one. Let's send only 5,000 bytes. If I do that, I send it again, start the traffic, see if it exceeds the burst. Go again to the show queue monitor length, and you see that it has exceeded the burst again with 600,000 bytes, and of course the syslog message is sent again. This is what I have demonstrated, and this concludes my demonstration on the LANZ functionality of the 7500 modular switch. Thank you, and hope to see you again at another demonstration of the power of EOS.